Hey guys, it's another video. This one is on multiplying actual matrices together. So last video was about finding multiples of matrices, which was multiplying a matrix by just a straight up number. Now we're going to be multiplying a matrix with another one. So this can be boiled down to you multiply elements of a row across in the first matrix, matrix A, let's say, with the elements of the column down in matrix B, then you add those products together to make the resulting product matrix AB. So keep in mind that when I say the resulting product matrix, that is the result of timesing matrices together, okay? Because the answer to a multiplication is always called the product. So that's a lot of words there. How can I simplify that even more? We can try by saying multiplying matrices involves multiplying rows with columns and then add the products together. So to illustrate that, let's do this example here. This first matrix has one row and this second matrix has one column, and so you have to multiply the rows across with the columns down and then add the products together. So A times by B is going to be 1, 2, 3 times by 2, 4, 8. And that comes to 1 times by 2 plus 2 times by 4 plus 3 times by 8. 1 times 2 is 2 plus 8 plus 3 times 8 is 24. 24, 25, 34. Alright. So you'll see the answer is just this matrix that's 1 by 1. For some things to notice here, you're only going to be able to multiply matrices together if the number of rows in the first matrix is equivalent, if the number of columns in the first matrix is equivalent to the number of rows in the second matrix. Let's say this first matrix only had 2 numbers in it. So let's say it only reached that far. 1, 2. And this had 3 columns. You wouldn't actually be able to multiply those together. Okay? So that's similar to the rules with adding and subtracting matrices. They have to have the same order. There's a particular rule with the orders of matrices being multiplied together, so be careful with that. Also, you'll see that the resulting matrix has the same has an order that is the rows of the first by the columns of the second. So this matrix here had one row, this one had one column, so the answer is going to be 1 by 1, so one element in there. So let's sum that up by saying, number 1, rules with the multiplying matrices. You can only multiply matrices if the first matrix's columns equal the second matrix's rows. Rule 2, the resulting product matrix has the rows of the first matrix and columns of the second. So if you had 2 matrices that have the order m by n and O and p respectively, you can only multiply them together if n and O, the columns of the first and the rows of the second, are the same. So you can't even multiply them together if they're not the same. And second, the resulting product matrix is going to have the order m rows and p columns. Okay, so still a lot of words there, but we have to get into it by showing some examples, but not before we get even more complicated. So the process of multiplying higher order matrices is going to be a bit tricky. You still multiply rows with columns and add products together like I did above, but there's a certain rule that governs the elements of the resulting product matrix. If matrix A and matrix B are multiplied to produce the resulting matrix AB, the element in the rth row and cth column of the product AB is going to be the sum of the rth row of A multiplied by the cth column of B. So that's a ridiculous sounding rule. The only way I can simplify that is to show you how it works, because that is how it works. I can't say it in any other way. If you're having trouble sort of getting that through your head and understanding what that means, you're going to have to look at how I do this and see how that works, because you're not going to get any notes or use of the calculator when you do this for your test coming up. Alright? So, concentrate. So here we'll run through some examples. We've got a few matrices here. A is 1, 3, 5, B there, C is there. I'm going to answer A first. A by C is 1, 3, 5 multiplied by 1, 2, 1, 0, 3, 4. So we've said you can only multiply matrices together if the number of columns in the first is the same as the number of rows in the second. This first matrix has the order 1 by 3, and this second matrix has the order 3 by 2. These are the same, so they can be multiplied, and the resulting matrix is going to be 1 by 2. So we already know what the answer is going to look like. It's going to have 1 row and 2 columns. So let's make space for that now. So how do we do this multiplication? You have to multiply rows by columns. So you go across the row and down the column. Go across the row, down the column. So let's do that. 1 here times by 1 there, plus 3 here times by 2 there, plus 5 here times by 1 there. That comes to 1 by 1 is 1, plus 3 times 2 is 6, plus 5 times 1 is 5, 6, 7, 8, 9, 10, 11, 12. So, I need to extend that. So this is just working out at the top here. This is the actual answer. And then the second column, we need to multiply that out with the row that's still here. So it's going to be 1 by 0 plus 3 by 3 plus 5 by 4. 1 times 0 is 0 plus 9 plus 5 times 4, 20. So this one is going to be 29. So that's my working out. So let's write that neatly. The resulting product matrix is 12, 29. Now with that answer there, I want to reflect on this rule to try and help you get that into your head, what it means. The element in the rth row and cth column of AB. So this is row 1, column 1 of the resulting matrix AB, well this time is AC, and this is row 1, column 2. Now, is the sum of the rth row of A by the cth column of B. So here, we're saying that the resulting matrix, this 12, needs to be the sum of the rth row, so the first row of the first matrix, so it's 1, 3, 5, times by column 1 of the second matrix. So confirming, how did I get this answer 12? I timesed row 1 by column 1. So that's sort of like a double check of your answer. You look back, how did I find that solution? It was row 1 by column 1. Why? Because this is row 1, column 1 of the solution. Let's have a look at this one. This is row 1, column 2. How did I get this number? Well, it's the sum of row 1 of the first matrix multiplied by column 2 of the second matrix. Alright, so hopefully that goes some way into clearing up what that rule means. There's no simplified way of illustrating that. Really, I don't understand how I could show it any other way than demonstrating it like this, okay? And with those words that I said. So try your best, see how you go, but it's not going to get any easier than that. B. So this question is asking me to find A by B. It's meant to be 1, 3, 5 times by 1, 3, 5, 2, 1, 3. This has an order of 1 by 3. This has an order of 2 by 3. These are not the same. Therefore, cannot be multiplied. These matrices can't be multiplied because the number of columns in the first matrix is not equal to the number of rows in the second, because rows in first are not equal to columns in second. Okay, so that's an application of this rule here. You can only multiply matrices if the first matrix is columns equal the second matrix is rows. Alright, so let's do one more as practice for this. C. We're multiplying A by C. A, C. Oh no, we already did that. What could we do? B times by C? Oh, that's what it should be. It should be B times by C. Because that's actually possible. Man, I can't even remember where I set up. B times by C is going to be 1, 3, 5, 2, 1, 3 times by 1, 2, 1, 0, 3, 4. Alright, let's check if you can actually do this. This first matrix, B, is 2 rows by 3 columns. This second matrix is 3 rows by 2 columns. These are the same. So you can multiply the resulting matrix. Result matrix will be 2 by 2. So we already know what the answer needs to look like, so that sort of helps you with the multiplications. You're going to need to have 4 sums all added together. Okay, if you do anything other than that, you've done it wrong. So this is row 1, column 1. This is row 1, column 2. Row 2, column 1. Row 2, column 2. So we're going to use this admittedly complicated rule to look back and work out what we need to do. The element in the rth row and cth column of the product is going to be the sum of the rth row of A multiplied by the cth column of B. So this rule tells us that here, this needs to be the sum of row 1 of the first matrix times by column 1 of the second matrix. So it's going to be 1 times by 1 plus 3 times by 2 plus 5 times by 1. That's 1 plus 6 plus 5. 6, 7, 8, 9, 10, 11. So this is going to be 12. Let's have a look at this again. Row 1, column 2. That tells us that the answer to this is going to be the sum of row 1 of the first matrix, B, times by the second column of the second matrix, C. So that is going to be 1 by 0 plus 3 times by 3 plus 5 times by 4. It's going to be 0 plus 9 plus 20. That's going to be 29. Let's have a look at this again. Row 2, column 1. That means that this is going to be the sum of row 2 of the first matrix times by column 1 of the second matrix. So that's going to be 2 times by 1 plus 1 times by 2 plus 3 times by 1, 2 plus 2 plus 3, 2, 4, 5, 6, 7. And then this last spot here in the result matrix, this is telling us that the solution is going to be the sum of row 2 of the first matrix times by column 2 of the second matrix. So it's going to be 2 times by the second row, 2 times by 0 plus 1 times by 3 plus 3 times by 4, 0 plus 3 times by 4 is 12. Alright, so that's going to be 15. So the result matrix in the end is 12, 29, 7, 15. Alright, so that is an example of the complex situation that multiplying matrices is, okay? First thing to get through your head is that they can only be multiplied if the columns of the first is equal to the rows of the second that you're trying to multiply, and then the resulting matrix, you can predict already what it's going to look like by the rows of the first, columns of the second. And then this whole process here, no other way to simplify it, that's what it looks like, is how you find out the solutions for each of those positions in the result matrix. So yes, hopefully that helps you out, and I will see you in the next video.